increasing and decreasing intervals, this lesson is it's going to feel like you're doing the same thing for a couple days. All right, so it's a similar process throughout this whole week. When the slope of a function is positive, the function is increasing. When the slope of the function is negative, the function is decreasing. So we can kind of look at this graph here to help us fill out the chart. So this is the graph of f, the original function f. At 2, all right, so at this point 2 here, what is the slope of the tangent line?
1 to 1.
Positive or negative?
Positive.
Positive. So at 2, I'm just going to put a little plus sign. All right, so at 2 here, I'm going to put a little plus sign. Because the slope at 2 is positive. Now, what's going on at 3?
It's changing.
It's 0.
Wait, hang on. Okay, never mind.
And then at 4 minus.
4 is negative.
5 is 0.
All right, wait. So 4 is negative.
Sorry.
6 is undefined.
6 is a cusp.
Yep. 5 is 0.
What did I say a cusp was the other day?
You said a different word. I can't remember what word it was. But.
I said something so retarded.
Oh!
Sorry.
Let's watch on it.
All right. Anyways, moving on.
You're lucky
At
Callie
6, what is the derivative at 6?
Undefined.
Undefined, because there is a cusp in a corner, so it is D and E.
He's shaking his jacket up.
To be fair.
All right, and then at 7, the derivative is negative. Shh, focus. At 7, the derivative is negative, and then at 8, the derivative is
Negative.
negative. All right, so we're going to kind of use that idea, and we're going to create sign charts. Now, we did sign charts back in pre-cal when we solved inequalities. Okay, but you got to think about the purpose of the sign chart. So the purpose of this sign chart is to figure out if the derivative is positive or negative, because if the derivative is positive, then I know my function is increasing. And if the derivative is negative, I know that the function is decreasing. All right, so the steps for the sign chart is first you are going to take the derivative and you are going to find your critical numbers. And you're going to put these numbers on your number line. Now, endpoints are not critical numbers. Endpoints would be like the endpoints of your number line. Critical numbers are just when the derivative equals 0 or when the derivative is undefined. Once you find your critical numbers, you're going to determine the sign of the intervals by plugging test numbers into the derivative. So once again, I don't want to plug into the original function if I'm trying to figure out increasing and decreasing, because that wouldn't tell me anything. I have to plug it into the derivative, because if the derivative is positive, my function is increasing. If the derivative is negative, the function is decreasing. And so from that information, then we can say what my intervals for the increasing and decreasing are. And then just as another reminder, this is different than finding extrema. Extrema is the very, very biggest y value and the very, very lowest y value. And so you do need to make sure you check your endpoints. So for extrema, you make a table, you plug them back into the original, and you figure out what the biggest and the lowest y value is of the original, because that would give you the max and the min. On this one, we want whether the interval is positive or negative of the derivative. What's up?
Will we eventually are we doing this so we can graph these?
Eventually, we are going to graph them, yeah. Mm-hmm. We'll sketch the graphs of like f prime and f double prime. That's next week on Tuesday.
So, wait, I have a question. When are we taking part 1? Because it never says part 1 up there.
Tuesday, the 16th.
Oh, so part 1, then part 2 on the 17th.
Mm-hmm.
Then the corrections on our final day.
Mm-hmm. Okay, so find the open intervals for which f of x is increasing or decreasing. All right, if I want to know something about increasing and decreasing, I need to take the derivative. So I'm going to take the derivative, which is,
X squared, and I don't know how to minus 3x.
yep. And then we're going to take the derivative and we're going to equal it to 0, and that's going to give me my critical numbers. So what's my GCF?
3. Why is it minus
3x.
3x? Because you multiply the 2 by the top number on the fraction, so that gets you 6, and then 2 goes into 6 3 times, so it's negative 3.
So your critical
Then
number
x
is
minus 1 on the inside.
1 and 0.
No, 3 becomes nothing. It's a GCF, right? Or is it? Oh, because it's 3x.
Minus
Yeah, so,
x minus
So
1.
3x becomes your right.
all right, so you take the 3x, and then on the inside you're left with x minus 1. Now we are setting this equal to 0, so you have to set each factor equal to 0.
0 and 1.
So your critical numbers are 0 and 1. Okay, so on my number line, I'm going to put my critical numbers, make them nice and big. Those are the important numbers. And we are going to take our critical numbers and we're going to plug them back into f prime. I like to write f prime right here because it reminds me of where I'm plugging my numbers into. So I put f prime down here. And if you want to write your test numbers, you can, but you don't have to. You can do it in your head. But what's a good number on the left side of 0?
Negative 1.
Negative 1. So if you want to write a little negative 1 there, you can, or you can just think about it in your head. But that's all this is a test number. It's not anything else. So when I plug negative 1 into my derivative, and I'm going to plug it into the factored version. That's the easiest one to figure out if it's positive or negative. So when I plug negative 1 into this guy right here, I get a negative and a negative, which would be
Positive.
positive. So I'm going to do a little plus sign, and I'm going to circle it.
And then 0.5.
And so then a number between 0 and 1, like 0.5. So positive, negative would be
Negative.
negative. And then a number on the right side of 1.
2.
So positive, positive,
Positive.
positive.
Didn't we do this in pre-cal?
But not with derivatives. So in pre-cal, we did it with inequalities. And so it was like less than or greater than. And if you wanted the less than, you wanted the minus interval. And then greater than, you want the plus interval. So in calculus, though, this is going to tell us stuff about f. So what I like to do is on top here, I'm going to write what I know about f. So since f prime is positive, what does that mean f is doing? Increasing. And if f prime is negative, what does that mean f is doing? And then here we would be increasing. So this is what f is doing. This is what f prime is doing. And making this sign chart and labeling the bottom f prime and the top f is going to help once we get into the second derivative and the first derivative test when we have f prime, and f double prime. And it gets a little bit confusing when you have all three. So I like to label so I know what's going on. All right. So now let's answer the question. I am going to be increasing from negative infinity to 0 and from 1 to infinity, decreasing from 0 to 1. Okay, flip. All right, same thing, increasing and decreasing. I got to do the derivative and find my critical numbers. Now, what rule do I have to do when I'm doing the derivative? Product rule. All right, so first function, which is x squared, what's the derivative of the second? E to the x plus second function, what's the derivative of the first? 2x. All right, and what am I going to do with my derivative? Set it equal to 0. Now on this one, GCF. All right, if it's not a trinomial factoring, think GCF. What can I take out of both terms? An EX and an X. Yep.
Okay.
All right, so when I take an EX and an X out of the first term, what are you left with? X plus, and then 2. All right, so every single factor is going to get set equal to 0. So e to the x gets set equal to 0.
Because that's what's left whenever you take the e to x and the x out. The x from the first one and then the 2 from the second one.
Okay.
Do you see it?
Can you see it?
Sorry.
Yeah.
I'll start throwing it in every once in a while. Can you see it? All right, so the x plus 2 set equal to 0, you get x equals negative 2. That's one of your critical points. When you set x equal to 0, you get x equals 0. That's another critical point. Now this is the tricky one, e to the x equals 0. It doesn't. Yeah, it doesn't. And so you just don't get any numbers from that. And if you think about the graph of an exponential, right, this is kind of what a graph looks like. It's got that horizontal asymptote here. Is it ever going to hit 0? No. So you just don't get any critical points from that one. Yeah, the air just kicked on. It's starting to get cold in here. Okay, so the two numbers I'm going to put on my number line are going to be negative 2 and 0. And we're going to plug our test numbers back into f prime. And remember, the factored version is the easiest one to plug it back into. Okay, so let's talk about the e to the x real fast. No matter what you plug into x, whether it's positive or negative, is the e to the x gonna be, it's always positive. And if you look at the graph, it's always positive. That's why it never hits 0, because it's always positive. So since it's always positive, I don't even care about the e to the x, because it's positive. It's not gonna change. So I'm really just worried about the x and the x plus 2. So when I plug in like negative 5, I get a negative and a negative, which is positive. And when I plug in negative 1, I get a negative and a positive, which is going to be negative, and then I'll have positive.
And then you write the F.
And so then I'm going to write what that tells me about f. So since f prime is positive, f is increasing. Since f prime is negative here, decreasing, and then increasing.
Was it coincidence that the arrows were the same on this one?
No, a lot of times they alternate, but not always, so you do have to check. All right, so I'm going to be increasing from negative infinity to negative 2, and then,
Oops, that was my test number.
yep, and then 0 to infinity, and then decreasing from,
Negative 2 to 0.
yep. Yeah, that's why sometimes I don't like writing the test numbers, because sometimes all the numbers get me confused, yeah. Okay. I'm going to do all the examples because I want to do a square root one, I want to do a trig one, and then I want to do a graph one. So I don't really want to skip any of those. Sorry. Okay. So for the square root one, first thing I'm going to do is I'm going to rewrite it with a 1/2 exponent so I can take the derivative.
Is that the only thing that's like different about the square root than a regular? Is you just write it differently at first?
A lot of times they're like this, a chain rule.
Oh, this is a chain rule?
Yeah.
Good.
But not, okay, yeah, because what's the derivative of the inside?
Wow.
1. So you don't really need it, but yeah, so 1/2 goes in the front. Inside stays the same, so the inside's going to stay x plus 3. When you subtract 1 from your exponent, it goes down to a negative 1/2, and then the derivative of the inside is 1. Which, do you really need to times the 1? No. All right, now I do not really like having negative exponents. I'm going to put it on the bottom.
Wait, so does the one on top become negative? Oh wait, no, never mind. I'm no. Just ignore what I said.
Okay, so I have my derivative. How do I figure out what my critical numbers are?
Plug it in.
So you will do
Plug
Equal to 0. Now, when you set the top equal to 0, is there anything to solve for?
No.
No. What about when you set the bottom equal to 0? Yes. Does the 2 matter? No. What about the 1/2? No. The only thing that matters is the x plus 3.
Wait.
Because if
So
you
x
divide...
equals -3. Because it'll end up being 0.
Yeah.
Whatever you do to it. Wait, for the 1/2 though, in the exponent, would you?
If you wanted to rewrite it as a square root,
Okay.
you could. Sometimes that
Then
makes it
you would
easier to
square
see.
it.
Yep, and 0 squared would still be 0.
Yeah.
Yep.
What's -3?
So I only have one critical number here, and it is negative 3. So on my number line,
It should split
Just, yep, negative 3. And we're going to plug it back into my derivative. I'm going to plug it into this form right here
Bless you.
that I've kind of simplified the best. Okay, so let's say I plug in like negative 5. Negative 5 plus 3 is a negative. Can you square root a negative? No, because you get what? Imaginary. So this part of your number line, it doesn't exist. It's an imaginary number. So when you do your interval, you wouldn't include any of this. It would start at negative 3. And then you can pick any number on the right side of 3, like 0, 1, it doesn't matter. But when you plug it in, what kind of number are you getting? A positive. So what does that mean?
It's just increasing.
Yes. So it's only increasing from negative 3 to infinity.
So you just don't put decreasing?
Yeah, you could either not put it, you could put never, none, DNE, yeah, NA, the 0 with the slash through it. But it's only going to be increasing. Okay, so I know the trick question on your homework, the one that I said I didn't want to do
Oh, yeah.
before because I don't want to confuse you. This one here. This one is a little confusing because of the x over 2. We've talked about it a couple times, but it's really not something I want to stress because I don't think it pops up very often on the AP test. I'm not saying it won't. I'm just saying it's not worth going over because it'll take too long to get you to wrap your brain around it. But what you should be able to do are the ones that are just regular x. All right, those are okay. All right, so we're going to start by taking the derivative. So what's the derivative of x?
0. 1.
1. What's the derivative of minus 2 cosine? Plus 2 sine. Yep. Because the cosine is negative sign, so double negative will turn that to a plus. The 2's just hanging out.
Plus 2 signs.
Yeah. All right, now what do I do with the derivative?
Set it equal to 0.
Set it equal to 0. What would you do first?
Probably subtract the 1.
Yep. And then?
Yeah.
Divide the 2.
Yep. All right, so now on my unit circle, I have to figure out when the sign value is going to be negative 1/2. All right, is sign x or y? The y. And so it's going to be this point here and this point here. All right, it's going to be negative, so it's going to be the bottom points and the 1/2, which is the smaller length. So it's going to be this guy and this guy.
Because it's the sign.
Yep.
I was just asking, Cameron.
All right, so then you got to kind of remember the radians. So this is 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6. So 7 pi over 6. And then 8, 6, 9, 6, 10, 6.
11 pi over 6.
11 pi over 6.
So,
All right, so on my number line, I've got 7 pi over 6 and 11 pi over 6. So what did I do?
what did I do?
There we go.
What?
Okay. So now I got to come up with my intervals. And so remember, we're going to plug them back into the derivative, the one that was most simplified, which is this one right here, 1 plus 2 sine x. So let's think of a number on the left side of 7 pi over 6. All right, so if you're talking about your unit circle right here, anything from 0 to 7 pi over 6 is going to be a number on the left side. What's special about these sign values? They're positive. So 1 plus a positive number? Positive. All right, so in between 7 pi over 6 and 11 pi over 6, which is right here, yeah, what's special about these sign values?
Negative.
They're negative. So 1 plus 2 times a negative number? Negative.
Can I just look at
And then from here, we probably can infer that this one's going to be positive. And it makes sense because if you think about it's a little sliver here from 11 pi over 6 to the end of my interval, which is 2 pi. But if this little sliver right here is positive, this one also is going to be positive. We can just kind of makes sense. Okay. So that's what's happening on f prime. So my f is going to be increasing, decreasing, increasing. Just be careful about your intervals because you're not going to infinity. You're starting at 0. So this interval here is technically starting at 0, and this one is ending at 2 pi. Does that make sense?
So 0 to 7 over 6.
Because it's on the unit circle.
Yeah. And then 11 pi over 6 to 2 pi is increasing, and decreasing would be 7 pi over 6 to 11 pi over 6. All right, so I think we hit a square root, we hit a trig, we hit a regular polynomial, and we're going to hit a graph. All right, so determine the intervals where f is increasing and decreasing based on the graph of f prime. Justify your answers. So this is f prime. This is not f. And you will have one of your answer choices probably be like it's decreasing from negative infinity to negative 2, which would be wrong because this is f prime. And I want to know when f is increasing and decreasing. Does that make sense? Okay. So what is special about f prime if you're increasing?
Oh,
It's positive. Yep. And what's special about f prime if you're decreasing?
A negative.
It's negative. Yeah, it's kind of like that position velocity stuff, except we've taken out the real life scenarios and we're just talking about f and f prime.
This is
So
much easier than the word problem.
yeah. If you are increasing, your derivative is positive because your slope. If you're increasing, your slope's positive. What tells you slope? Derivative. All right, so it all kind of relates. So when you're looking at your derivative graph, because this is derivative, you are positive here to here and there to there. So I would say we're increasing from negative infinity to negative 3 and from 1 to 3. And then you would be decreasing from
Negative 3 to 1.
mhm.
3 to infinity.
And the justifying part is this. Oops, that just erased. All right, so for justifying, all you have to say is something about f prime being positive or negative. You can say with words, or you could do the little math notation. Does that make sense? Okay, so just be careful with the graphs and just really wrap your brain around what is given, what is it asking, and what is the relationship between those two things. Because there'll be some kind of connection between f and f prime, and that's what we're going to be talking about for like the next couple days. All right, so we're going to be talking about it a lot. So this lesson, like, just keep building on it. It doesn't get harder. We just like really get a good understanding about it because there's a lot of questions on the AP test that are asked about this stuff.